This is the practice for patterns and relationships found in right triangles, and I'm going to work through some of the problems for you. Please, I hope that you try them yourself first and then look through this. The first two problems, it just says determine if a triangle with the given side lengths is a right triangle. So all we need to do is see is a squared plus b squared equal to c squared true. So a squared plus b squared is equal to c squared. And then keep in mind that c always has to be the biggest side. Looks like they put them in the right order, but you do need to check. So that means is 10 squared plus 24 squared equal to 26 squared. 10 squared is 100. 24 squared is 576. And 26 squared is 676. If you add here, you get 676 is equal to 676. So yes, we do have a right triangle. Okay, let's go ahead and look at the second one as well, because we have these square roots. So again, is a squared plus b squared equal to c squared? So is the square root of 1 squared plus the square root of 2 squared equal to the square root of 3 squared? Okay, the square root of 1 squared, that is the square root of 1 times the square root of 1, which is equal to the square root of 1, which is 1. Okay, let's look at the square root of 2. That is the square root of 2 times the square root of 2 is equal to the square root of 4, which is equal to 2. So this is 1 plus 2. So hopefully you'll already know what the square root of 3 squared is, but the square root of 3 times the square root of 3 is equal to the square root of 9, which is equal to 3. So yes, the square root of 1 squared plus the square root of 2 squared is equal to the square root of 3 squared, because we get 1 plus 2 is equal to 3. So yes, indeed, this is also a right triangle. Okay, so now find the length of the unknown sides in the triangles. It says, hint, use the Pythagorean triples. All that means is that if you have a list, if you can think of, are these triples, that's great. But if not, it just means do Pythagorean theorem. So on the number 3 here, okay, we notice that this is C. So this is a squared plus b squared, 28 squared, equal to 35 squared. Okay, so this would be a squared plus, and 28 squared is, I'm going to have to do it in my calculator, 784. And 35 squared is 1225. So I'm going to subtract 784 from both sides. And I get 441. So a squared is equal to 441. And then we just take the square root of 441. And it is the square root of 441 is 21. So yes, this is a Pythagorean triple because we have an integer answer for a squared plus b squared equals c squared. Okay, I'll leave number 4 for you, and let's scroll down. The perimeter of a square is 44 meters. Find the length of the diagonal of a square. Okay, I'm going to start with the square. And the perimeter is 44, and there's 4 sides. So if we do 44 divided by 4, we get 11. So each side is 11. And we want to know the length of the diagonal. So there's 2 different ways to do this. One is you can do Pythagorean theorem, and you're going to get a decimal answer. And if they want the exact answer, that's not the one they want. But we say 11 squared plus 11 squared is equal to c squared. Okay, so we can do it that way, and we get 121 plus 121 is equal to c squared. If we add those together, we're going to get 2 242 is equal to c squared, and c is equal to the square root of 242. And we're going to have to look for a way to rewrite that to simplify the radical. Okay, but if you think back to the notes, there's a much easier way to do this problem. So let me clear this so I can show you another picture. So right now we have the square root of 242. Okay, I'm going to write that up here. We can simplify that, or we can go back to the pattern that we said always exists in a 45, 45, 90 triangle. And that pattern was the lengths of the legs are equal to x. The same thing, could be anything, but the length of the hypotenuse is equal to x to the square root of 2. So anytime you have an integer answer for x, in this case, these sides are 11, that means this side is 11 times the square root of 2. Or, if we were going to rewrite this, how did we get 11 outside of here? Okay, this is your answer. That means inside of here we took an 11 out, so this was 11 squared is 121. So that means we could have rewritten 242 as 121 times 2. And then we take this, and that equals the square root of 121 times the square root of 2. And the square root of 121 is 11 times the square root of 2. Okay, but what we want to do is work with the patterns because it saves us a lot of work. Anytime you have a right triangle with the angle measurements 45, 45, and 90, we have x, x, x to the square root of 2. So if you have a problem and you know that the length of this side is 13, that means the length of this side is 13 times the square root of 2. Okay, let's scroll down. I'm going to leave you 6. Let's go to 7. The length of the diagonal of a square is 12 inches. Find the length of the side of the square. Okay, this has the same pattern, but this one's a little more tricky. Okay, we have a square. This time we have the diagonal is 12. All right, so the way again we can write our pattern, let me just write the 45, 45, 90 here. Okay, and so what they're telling us is, well, we have x, x, and x to the square root of 2. So what this diagonal is 12, so that is telling me that x to the square root of 2 is equal to 12. So my picture tells me x to the square root of 2 is equal to 12. So what I need to do is solve for x. So I can divide both sides by the square root of 2. And I get x is equal to 12 divided by the square root of 2. Now that is the correct answer. And if your problem allows a decimal answer, you could put that in your calculator. You could put 12 divided by the square root of 2 and you're going to get a decimal. But most of the times here, you're going to want an exact answer. So what that means is I have to, if you remember the term, rationalize the denominator. In other words, we have the correct answer, but we have a radical in our denominator, and we must get rid of that. So we're just going to multiply by the square root of 2 over the square root of 2. Because in the bottom here, the square root of 2 times the square root of 2 is 2. So I no longer have a radical. I couldn't change my answer though, so I had to multiply by some form of 1. The square root of 2 over the square root of 2 is 1. In the top I get 12 divided by the square root of 2. And now I can simplify one step further because 12 divided by 2 is 6. So my answer is 6 divided by the square root of 2. Okay, now here's another pattern, and we mentioned it the other day. Anytime, I'm going to draw the picture here, anytime that you have a radical answer here, I'm sorry, an integer answer on the hypotenuse in a 45, 45, 90 triangle, the sides are half of that times the square root of 2. So we know the sides are 6 to the square root of 2. In other words, if you have another one, and if this is an integer over here, if this side is an integer, like 10, this side is going to be 5 times the square root of 2. If this is 9, this is going to be 4.5 times the square root of 2. Okay. Let's go ahead and look at number 8 while we're here, because this time they give us the diagonal of a square. So we know again that's going to be a 45, 45, 90 triangle is 15 times the square root of 2. So this one, again, we're just looking at the pattern x, x, x to the square root of 2. So if they already gave us this side as x times the square root of 2, if this is 15 square root of 2, this is just 15. We see the pattern x, x, x times the square root of 2. All right. Let's go down to, let's look at number 10. This one is the 30, 60, 90 triangle. This one is the one that's a little bit different, okay? So the pattern that is found in a 30, 60, 90 triangle is the side across from 30 is x, the side across from 90 is 2x, and the side across from 60 is x times the square root of 3. So we have x, 2x, and x times the square root of 3. So in this picture, it is telling me that each side of the equilateral triangle, so this one is 9, is equal to 9. Okay, this is always going to be an equilateral triangle. When you have 30, 60, 90, and this is 90 right here. And then this line right here bisects the base. That's how we get half of 9. Go back to that color. So 2x is 9, so half of 9, 1x, is 4.5. And then the side across from 60 is just x, or 4.5 times the square root of 2. So hj, 3, I'm sorry. So hj is 4.5 times the square root of 3. And ji is 4.5. Okay, we're going to work a lot more on 30, 60, 90s in the next couple days. I hope this helped.